Good morning, everybody, and welcome to the RACF version 2.4 for ZOS 2.4 update and Chocolate Festival. Yes, it's not cheating. This is a way of getting you guys to do what I really want you to do, which is start asking questions. Again, Mark Nelson, RACF development team. I've been with RACF for 32 years. I absolutely love the product, and I love the product mostly because of the people. The technology is fun, but the mission of the product, security in general, it's one of the mainstays of the platform. And it's just so much fun to talk about. So, again, chocolate, questions, answers, 1 hour, let's get going. So we're going to cover a lot of material. Now, Mark, you had 50 some odd charts in 30 minutes. You did them all. I am very, very impressed. I have 50 and I have an hour, and I still won't get through them, but that's okay. We're going to go through all the stuff that's new in 2.4, and that's ZOS 2.4. And I will also point out a few of these things that are rolling back to earlier releases. So how many of you are running on ZOS 2.3? Show of hands, show of hands. A lot of folks on 2.3, excellent. 2.2? A couple of folks, that's okay. 2.1, out of service, just wanted to remind you about that. Unless you want to pay IBM a lot of money, we're happy to take it. So most of the stuff is 2.4. A couple of things go back to 2.3. I won't bore you with the list because I'm going to bore you with the actual technology. Thank you to our general session speaker this morning for mentioning the Z15. I will try to remember to call it a Z15 because from a security perspective, there's stuff there that I think is of interest to everybody. The first of which is it's bigger, it's faster. That's always good. More transactions through. Wonderful thing to have. There's an on-chip accelerator for compression. Why is that of interest to people who do security? Because if you're encrypting data, it's far more efficient to compress it first. Right, so you can get some performance advantages there. I'm not going to talk about that, but it's an important part of the architecture. The speed up for what we're calling it the system recovery boost, that is for planned or unplanned shutdowns, IPLs, things like that. You can unleash the full force of the processor to get you through that process and substantially reduce the amount of time required to do that. For the new folks, rebooting. For the old folks, IPLing. We have improvements in the overall crypto performance, system SSL with the Crypto Express 7S. Yes, we're continuing our tradition of naming our Crypto Express cards after iPhones. Still have right to do that. And there's a statement of direction that we're going to be encrypting the data as it goes through the storage fabric, if you will, the FICON environment. Statement of direction, all just background stuff about what's on the Z15. There will be other sessions this week to talk about that. And by the way, a special welcome to the folks who are watching on YouTube. Everybody here knows if this session is not the session that you want to be at because of wrong material, bad speaker, whatever it might be, feel free to get up and exit and find the right session. We want that to happen. If you're watching this on YouTube, hit pause and watch a cat video. I don't care. Pass ticket enhancements. We came up with pass tickets back in the 1990s, in RACF 192, I believe it was. And the concept of a pass ticket was a password substitute, an 8-character value that would be accepted just like a password. Now, a pass ticket was generated based upon a user ID, an application name, a time value, and a shared secret. Right? And those 4 things together, you put them into an algorithm. The algorithm is publicly known. It's in RACF macros and interfaces. You can generate these things off platform, and any place you could use a password, you could use a password ticket. That's great technology. We designed it initially for secured sign-on products, single sign-on types of products, but it's used all over ZOS. Some applications will generate a pass ticket in one address space and then pass it over to another address space to create a security context over there. The key thing about this, by the way, is this shared secret, this key value. Now, this key value can be specified in a couple of different places. The first one is, and in general, if you're given a choice, and the choice is somewhere or ICSF, where do you think the better place is? ICSF, everybody who thought that, grab a chocolate on the way out, right? But we did give you the option of storing it in the RACF database as a masked value. Now, in general, if there's a security person, if I hear the word masked, I go, just a little bit. Because you want to hear that something is actually enciphered, encrypted, and stored very, very securely. But we gave folks the option because back in 1992, not everybody had ICSF. But now we're at a point where ICSF really is fundamental to the secure operation of the ZOS environment. Right, so if you're defining this thing called a pass ticket, you'd give it, it's a profile in the PTKT data class, you'd give it a name. The segment you'd put this key in is the S sign-on segment, and you'd say key masked, put it in the RACF database, or key encrypted to put it in ICSF. Note that anyone who has access to that key material has the ability to generate one of these pass tickets for a user. And that's really why you need to keep those keys as secret as you possibly can. When you go on, you R-list those things, we don't give you much information. If you say R-list, my Apple, and you ask for the stuff that's in the S sign-on segment, in the old days, we would say key mask data not displayable. That says it's a key mask key. If it was a key encrypted one stored in ICSF, we would say key encrypted data not displayable. Well, now in version 2.4, we will actually give you, if it's stored in ICSF, we'll actually give you the key name. That's part one of the ICSF enhancements. We'll talk about the second one in a few moments. In addition, in all the places where you can ask for information about that secured sign-on segment, and to get that key label value, such as database unload, radmin, irxutil, they will also export it now as well. That's pretty cool. Now, if you have a key that is stored in ICSF, stored in RACF, we are giving you the ability to move it into ICSF without having to do anything fancy. Literally, all you do is you do an R-alter and you use S sign-on and a special keyword, encrypt key. That will instruct RACF to take that key label, and if you have ICSF set up and configured, we'll put that key into ICSF, generate a key label, and store things. So now you're in a much more secure mode for the protection of the very sensitive information. If you want to do it for all your keys, I hope everyone here, how many folks here are RACF administrators? A couple of folks. Are you familiar with the search command and the power of the search command? Well, you can use the search command to go out and get a list of all the users and automatically generate a C list that will convert, actually I said all users, all pass tickets, and convert all of those pass tickets that were stored in RACF and get them into ICSF. And that's the example there.
So Mark,
Yes, sir.
are you going to erase the old version of mask data out of the...
So the question is, do we erase the old version? I believe the answer to that is we go through our normal deletion process, which I think is going to mean, and I do need to verify this, I think is going to mean that that data will remain in the RACF database. I have to validate that. Now, why is that of a concern?
Well, if the aim was to make it more secure by putting
Yeah.
it in ICSF, you don't want to leave it flying around the real world before.
That's absolutely true. That's absolutely true. However, if somebody has access to your clear text RACF database, you have other avenues of attack that might be a little more significant. But excellent point. Excellent point. You need to protect your RACF database as well as you protect probably the most sensitive piece of information that you have. Really does need to be protected. I will also point out that if you run a utility like UT400 and reorg it, that will get rid of the dead space and will get rid of that dead value. Excellent question, Lee. Thank you. Okay, so what else do we have here? Creating a pass ticket. If you want to pre-create your ICSF keys, we're now giving you the ability to do that. You can now specify, when you're defining that pass ticket, you can give us the key label that represents the key that you've already put into ICSF. Right, so this way, when we were generating the key labels, it was our format, right? You can now generate key labels using whatever naming conventions you have for your key store. Cool stuff. The last of the ICSF enhancements is when you were using ICSF prior to ZOS version 2.4, you had to do a little bit of an installation tweak. There were some ICSF modules shipped in LPA, and we made you go out and do some magic to make that happen. You no longer have to do that in ZOS 2.4. So a couple of other enhancements to pass tickets and their practical use of them. What happens if a pass ticket is presented for evaluation and it doesn't evaluate successfully? Perhaps it's out of time. The date range is invalid, as an example. Well, it turns out that back in ZOS, when we did our MFA support a few years ago, I guess it would be, we introduced a new SMF relocate section, SMF relocate section 443. And in there, we put a lot of additional information. We did it originally for MFA, but it turns out it has a lot of use in other cases. So in any case where an SMF a job initiation record is being written, not the type 30 style one, but the RACF style one, we put information there about the ACEE. And in this 443, what we're going to put is if a pass ticket was presented, we will give you some diagnostic information as to, if it failed, why that failed. So for example, there's return and reason codes, which you can then map to the specific reasons why the pass ticket was rejected. There's some other information that's useful in there, so if it failed because of time, you get an indication of what the time offset was and the application name that was used in the validation process. In addition, so that's all when you're using RAC request equals verified to process these kinds of things. We also have a callable service that's based off of the RCVT PT gen, right? And if you're generating a pass ticket and it ends up not being able to be generated for one reason or another, now there's going to be a failing return code returned back to you in register 0, which you can look up in macros and interfaces, see what's going on. So that should make, for those of you who are writing code, that should make things simpler. Questions on that? All right. Custom fields. How many of you use custom fields? Yeah, almost everyone. One of the most popular things we ever did in RACF. And the concept here is we know what information we wanted to define. We know what information other IBM components wanted to define, TSO, CICS, whoever. But we didn't give you a convenient way for you defining the stuff that you wanted to define, your own fields, custom fields in the RACF database. So back many, many releases ago, we gave you the ability to do custom fields for users and groups. And the concept with this was very straightforward. You do a little bit of setup, we'll show that in a moment, and then you could use the normal RACF commands, alt group, alt user, list group, list user, things like that, to see this information, these custom fields displayed as part of the normal RACF commands. The magic occurs with profiles that you create in the CS data segment. And what do they look like? Well, R-define, C field, custom fields, that's a class name, and then you define the field, in a profile. The first part of the profile was the class, in this case user. The second one was CS data. The third field was the name of the field that you actually wanted. In this case, EMPSER for employee serial. And then in the CF def segment, you describe what that field looked like. You know, this one is a numeric value. The first character must be numeric. Every other character must be numeric. It can only be 8 characters long. Its minimum value is 100,000. Maximum value is a whole bunch of 9s, some help text. All of this will be used by the RACF dynamic processing to manage your custom fields. Then all you have to do is make sure that the C field class is active. You have to run the dynamic parse update utility IRDPI00. And now, alt user, the user ID here is Coop, guy I work with, CS data, open paren, EMPSER, 1, 2, 3, 4, 5, 6. And then when you list that segment, you see all of that information. Life is good. And everyone loves this, except for one thing. We did it for users and groups. But what about data sets and general resources? It turns out there were some complicating factors, data sets in particular. With a data set, you can have, how many discrete data set profiles can you have of a particular name? The answer is an arbitrary number because a discrete data set profile has volume serials. So, well, yeah, you can, yes, you can. And people still do that, Mark. So that was one of the complicating factors. There were others. But finally, in ZOS 2.4, you now have the ability to have custom fields on data sets and general resource profiles. And it works exactly the same way. The big difference is the first qualifier. And the first qualifier before it said user, or it could have said group. Now it can say data set, it can say general for general resources. Everything else is done the same way. So you still have to make sure the class is active, you have to run dynamic parse update, et cetera, et cetera, et cetera. So the one thing to note is all of that validation that I talked about, minimum value, maximum value, stuff like that, that will be done for all profiles, all general resource classes, I should say. So if you want to do any more validation, you'll be writing some Rex exit code of your own. Question? Perfect. You know what? I'm giving you a chocolate for asking the question. And I'm keeping one for myself for anticipating it. And I can do that. There is a new valrex keyword that you can use to drive system rex exits for the purpose of doing validation of data that comes in from a RACF command. It's supported for all types of classes. And you can share a particular valrex exit across multiple fields. Nice stuff. Questions on that? Cool. So in order to make that work, we had to make a whole bunch of infrastructure changes. And those infrastructure changes are actually externalized through things like radmin and IRXUtil. So the radmin callable service, how many folks use radmin? A couple of folks. It's a great interface. It allows you to do so much stuff. You can retrieve information about profiles, user groups, general resources, but not dataset profiles until COS 2.4. You can retrieve information about setter ops or your system setting. You get information about the RACF remote sharing facility. You can also use it to update profiles in the RACF database and update system configuration settings. We're not going to talk much about those. Is anybody doing that? I know internally we have some products that do that, but so what's new? You can use this utility, this functionality is now available for dataset profiles. But once again, when anytime you're talking about retrieving information out of RACF, there are always going to be some gatekeepers and some controls. In this case, if you want to retrieve information about dataset profiles, you'll need read authority to ir.radmin.listdsd. Exactly consistent to how we treat all of the other information in the RACF database. Let's talk about IRXUtil, the REX interface into the RACF database. Show of hands of folks who use this. Not everybody. Okay, how many folks here write REX but haven't used IRXUtil? Okay, so it's, well, okay. So here's my theory. I love REX. It's my second favorite programming language. I love the simplicity of IRXUtil. And I will tell you right now, I had nothing to do with the development of it. I wish I had. I think it's one of the coolest things that we have done in RACF. So the concept of IRXUtil is you can retrieve information about the RACF database. Things like profile information, users, groups, general resources. Oh, wait, not data sets until ZOS 2.4. You get setter ops information, you get RACF remote sharing information. I think you could see a little parallel here between IRXUtil and RAdmin, because IRXUtil is built on top of RAdmin. So when we enhance RAdmin, we can extend those enhancements into IRXUtil. So guess what? You can retrieve information about dataset profiles. Yay! I say that yay because there's a user conference I go to. For the last 8 years, they have submitted a requirement that says we want to have IRXUtil support for datasets. They submitted it maybe 8 years ago, and then the next year they just took the last year's requirement, photocopied it, and handed it to me. And then every year since then, we're just looking basically at the same requirement over and over. And as a developer, it thrills me to be able to say, it's here. So have at it, it's a lot of fun. But in addition to that, we've updated IRXUtil so you can extract information about the class descriptor table. So if you want to go out and find out what classes are active, positive value information, all kinds of stuff like that, you now have a REX programming interface to go out and get that. And that's nice and huge. And when retrieving information about these CDTs, I'll just point out that it supports both the IBM-defined classes, the static classes, and any classes that you may have defined as dynamic general resource classes. Questions on that before we move on to topic, whatever the number is, next? Okay, how many of you are using the RACF remote sharing facility? Wow, lots of folks. Excellent. So to review so you all know what RACF remote sharing facility does. It lets you share your RACF database across physically disparate environments. I can have a RACF system here in London and a RACF system back in hometown of Poughkeepsie. Could you have DASD connectivity to share a RACF database? Not yet, at least as far as I know. But you could link them together using the RACF remote sharing facility. Came out in the mid-90s as part of RACF version 2.2. So the concept is, when a change is made on one system, it is propagated via APPC, originally TCP/IP as the more current and modern alternative, to the target system or target systems. So you can have a network of these RSF images, right? Each of which is communicating back changes made to it. So there's a lot of power in what we do in RSF. Now, how does this work? It's possible that if I'm making a change at a system here in London, my New York system isn't available. So the information gets queued in a pair of VSAM datasets. There's actually a pair of VSAM datasets for every system that you're communicating with in this RSF environment. The information that we store in that database is it's masked. Remember I said masking is a bad word. The reason why it was masked is that was the maximum amount of stuff that we were allowed to do by certain organizations that regulate what you're allowed to do. And it was a DES-based masking, but wait, it's worse than that. It was what was called CDMF, Commercial Data Masking Facility, which is 40-bit DES. Right? Not a big fan of that. But that was your option for both communications and for the storage on the database. With the use of TCP/IP, what you get is all of the security you can get with TLS, and that's really good, right? So how many folks are still running APPC and RSF? Okay, it's a thought. Consider moving. The migration, and I'm going to point, I bring this up for a specific reason, but it's a much better place to be. But it turns out when we did the work to go out and enable the migration from APPC to TCP/IP, and I love putting all those letters together at once, that's so cool. Buzzword bingo, I love it. When we did that work, we created a mechanism by which RRSF could quiesce its work in APPC, pause, and then restart in TCP/IP without requiring you to shut down your RRSF network. And that was key because one of our developers figured out, you know, we could go out and take advantage of what we had done back in ZOS 113 and create a mechanism by which you could reallocate your VSAM data sets, these data sets that are used to store information outbound and to receive information coming inbound. Now, there really wasn't much of a reason to do that. How many times do people change their underlying RSF VSAM data sets? Never. There's really, the only reason I could think of is if somebody said you have to abide by some new naming convention. That's the only reason I could think of. But there's another reason now. As of, ZOS 2.2, you have the ability to encrypt your VSAM data sets using pervasive encryption. So if you go out and take your RSF data sets, right, and say, I am going to go and move from this set of RSF data sets to this set of RRSF data sets, and these just happen to be defined as pervasively encrypted data sets, you've just encrypted your RRSF inbound and outbound data sets. And that's huge. And I think a lot of folks miss that in our publications and announcements, so I point that out here. That's the real value of this, being able to use pervasive encryption. A little later on, I'm going to ask you how many folks are using pervasive encryption. I was hoping it would be about 100%. It's not. All right, next topic, ACEE modification detection. Last year at this conference, I did a session called The Life of an ACEE, and it was really meant to be a stepping stone to this discussion. So let's review what I talked about there, the accessor environment element. What is it? It's a control block. It's a piece of storage whose purpose is to define your security characteristics, or more generally, a user's security characteristics to the operating system, to ZOS. It's not a RACF control block, one of these interesting pieces of trivia. It's actually a control block owned by the BCP, the Base Control Program. It's owned by MVS. In reality, the RACF team does all the development on SAF, so it may be a separate part of the operating system. That's more of a paperwork exercise than anything else. The real meaning of that, though, is that all of the products that do security on ZOS, all of the external security managers have to honor the ACE, have to create it according to certain rules. Now, what's in the ACE? Well, it's the identity of the person or the task that is doing some work. So we can think of that as a user ID. All of the other credentialing information is also there. So you'll see a list of groups. You'll actually see two of them. One of them is set at the time you log on, at the time the ACE is created, and another one can be changed later on based upon environmental things. It can be changed by rack route request equals auth in particular. You'll also see in there a list of the authorities that that user has. The really important authorities, like special, like operations, like auditor. You'll see in there pointers to very important control blocks, like the token. And in the token, you'll find some very important fields, like the trust field. There's also a lot of environmental information there. How did this unit work come into the system? Was it a batch job, a TSO session? What was its port of entry? Now, who uses the ACE? The answer, well, RACF makes extensive use of it, but a lot of other components do as well. It's the place RACF is going to look to see, do you hold one of those special credentials, special operations and order, to allow you to do certain things in RACF, right? So it's a key piece of storage. How many of them do you have? Well, at least one, possibly multiple. Why could there be multiple? Well, this control block is anchored in a couple of different places. Every address space has one. The address space control block has an extension, the ASXB, and in the ASXB there's a pointer to the ACE for the address space. But wait, there's more. Every unit of work, almost every unit of work, every normal unit of work is represented by something called a TCB, a task control block. That task control block can also have an ACE pointer. The idea there is if I have an address space that has multiple users in it, I can have a security environment associated with each task. And whenever RACF is going to make an authorization check, it first looks at the task level 1, and if there's none there, it then looks at the address space level 1. But wait, there's more. You can also have these accessor environment elements, these ACEs, literally sitting in storage, waiting for use by a resource manager, like CICS, as an example. What happens here is the resource manager, it kicks in this case, creates the ACE, and when it wants to do an authorization check for that user, it says, hey, RACF, does the user represented by this ACE in storage, and it points to it, have the authority to this transaction or whatever it might be? Right? So these accessor environment elements can exist in lots of places. That's about as geeky as we're going to get. Here's the payoff. It's an important control block. If somebody has the right privileges, they could change that. Now, to make those changes, you have to have a fair amount of privilege. From a storage management perspective, not disk storage management, real memory management, you have to be running in key 0 because the storage is key 0. Right? What authority do you have when running in key 0? Answer, you can read or update pretty much any storage, including this. Right? How would you get the authority to run in key 0? Well, there are lots of different ways. I'm sure the pen testing sessions today will talk about some of them. One of the big ones is if you have the ability to put a module in an APF authorized library. All you have to do is be able to put it there, link edit it with AC code 1, and do a couple of magic little assembler things which everybody knows, one of which is called mode set. So it can be altered, and it may well be being altered at your shop. That's not necessarily a bad thing, because it turns out there are some products that you probably use or have used that have been doing this manipulation of the ACE in the background to simplify your life. Right? And you trust the vendors that do that. Right? The danger you have is if you have someone who is doing this manipulation for reasons other than for your benefit. So, wouldn't it be nice to be able to detect when these modifications are being made? And that's what we're talking about with the ACE modification detection. The concept here is if somebody has flipped one of those bits that gives you more authority, we'll recognize it at the first time that you attempt to use that ACE. And I'm going to be very specific. It's not any attempt. It's the first time RACF does an authorization request, specifically a RAC route request equals auth for that ACE. Now, the way this works, when the ACE is created, RACF is creating a thumbprint of what is in the ACE. Actually, what's in the security port, the security sensitive pieces of the ACE. We create that thumbprint and we squirrel it away somewhere. Don't worry about where it is. Because I know that there's at least 8 people in this room. And where do you, I'm not telling you. Make you figure it out on your own. So then when we do that RAC route request equals auth, where that ACE is used to actually do an authorization check, we will go out and compare the thumbprint of what is in there against what is in there now. And if we notice that something has been elevated, we will give you a message. It really is that simple. And I'm trying to use the word elevated. I didn't say changed, I said elevated. If you had an ACE that was created with a higher level of privilege and you decided to downgrade it, or somebody decided to downgrade it, that's okay. So when you get this message, it's not just any change, it's a change that represents an increase in authority. So it includes the things you'd expect, special, the toke trust field, all the things that we think are critically important. And no, we don't tell you what all those are because they may change over time. The concept here is if it's changed, we're going to alert you and then you got to figure out what's going on. All right. This is one of the things that is rolling back in entirety back to ZOS 2.3. The APAR is there. And the link there is a really good document that describes how this is being done, why this is being done, and gives you the explicit changes in all the books. So questions on this? Yes, sir.
I've played around with this in 2.3.
Yes.
And one thing I've discovered is that if you steal somebody's ACE of a logged on special user, that doesn't detect.
So the point here is that you've been playing with this, and if somebody steals an ACE, pray tell what does the one mean by steal an ACE?
It's a catch-all term. I don't know the full technical term. If there is a logged on special user and you were to run some elevated code from an ACF library to take their ACE and overwrite your own with theirs, so you do a list user and now you look like that other person, that doesn't hurt anything.
That's an excellent point. So the concept of stealing an ACE is basically, we have to talk about the concept of the trusted control block chain. Right? So I mentioned before the ASXB, the address space version, or the TCB level. By stealing it, I think what you mean is you took an ACE that had been created somewhere else legitimately, and you changed that ASXB point. Yeah. Yep. Okay. So that's a really interesting case. In order for you to have done that, you had to be running key 0. Right? You had to be able to do that. In a sense, you didn't change the ACE. Right? You presented a perfectly valid, I'm trying to think of a currency example. You presented a perfectly valid 5-pound note, but it wasn't yours. It was somebody else's. Yeah, RACF, this will not detect that. Good point. I like that. Other questions? Sir?
This is just automatically enabled, is it something like that, or not?
Oh, just hold that question because rats, there's going to be documentary evidence if I hurt somebody. Perfect cat. If it's not on videotape, it didn't happen. So the question is, do you have to do something to make this happen? The answer is yes, you do. You have to activate the ACEE check class, and that's pretty much it. Right? So if you don't enable that class, you see nothing. If you enable that class, you might see nothing. Your console might be overrun with messages. You think you'd be overrun? We'll let you guys squabble amongst yourselves. I'm going to probe a little bit. Are these things you've done for testing purposes?
They're a software house, Mark.
Yes, understood. If you're doing it for that's a perfectly valid reason. I'd be much more concerned if in your production, billing, whatever it is environment, you would be overrun. But in a test environment, absolutely. Absolutely. Because we all have test tools that do stuff like this. Absolutely. So that's not a problem. So that's the message that you get. IRR 421I. Oh, yes.
For a customer,
Yes.
I'm speaking from a software vendor point of view here, for customers who's thinking about implementing it,
Mm-hmm.
is there a list of vendors that have certified their product to say that you will not see an IRR 421I?
So the question is, for a client who chooses to turn this on, is there a list of vendors, perhaps for whom we could create a list of exceptions, and we'll talk about the exception process in just a moment. I am not aware of such a list, but I will point out that we have been playing with this internally for a very long time. We have a very active partners, what's it called now? Not Partner World? I don't know what they call it anymore. Partners in Development, thank you. And the vendors have all been exposed to this. And I will tell you, one of the reasons that I won't say held back on doing this, but one of the complicating factors is we had to work with a lot of vendors and teach them what was being changed and what they could do to fix it, right? So those vendors who participated have taken care of it. Those IBM products, and there were some IBM products that had to make some changes, have also made those changes. But is there a list? Not of which I'm aware. I actually went by something here. At least I think oh, no, it went only big, no! For those of you who weren't in the room before, it took us forever to get this going. All right, so we're going to go rip through this. Any questions? No? Custom fields, data set profile. I apologize, not my laptop. My God, we've done a lot.
We should just edit the video just about this past piece in the video.
We could, but this is so much more entertaining. Don't edit that, please. Okay, so this goes back to your question of if you see a lot of these, what does it really mean? So there are a lot of reasons why this ACEE modification might have been done. It may have been that the vendor had no other choice because this technology, this architecture has been fixed for many, many, many years. So it may have been that you have an application that's running that really doesn't know what resources it's going to need access to. That based upon what the application is doing, it's going to do, think of a storage management product as an example. It doesn't know what data sets it's going to trust. So what we'll do is we'll do our own validation to make sure that you're allowed to do this thing. We'll flip this bit on, and then you won't have to define RACF profiles for every data set that you have in your organization. It's a perfectly legitimate thing to do. It turns out there are alternatives nowadays. One of the alternatives we were discussing a little earlier Our friends over in DFP, the data facility product, the access method. 2 or 3 years ago, they came up with a way on the data definition, on the DCB or the DEB, I can't remember which, to say that when this data set is opened, I want RACF to be bypassed. Now, to do that, you have to be authorized. You have to be running APF authorized, I think, in their case. So not just anybody can do that, because if anyone can do that, game over. Right? But that meant that if you were a resource manager that was opening arbitrary data sets, you don't need to set it up you don't have to manipulate the ACEE to say, I can open anything. When you're actually opening the thing, you can say bypass RACF. That's a huge advantage. That's a wonderful step forward in technology, but the resource manager has to make a change to take advantage of it. Right? Many of them didn't. Right? A lot of them stepped up to it once we started doing the ACEE detection. Right? So there are legitimate reasons, but there are also illegitimate reasons. And it is well known if you look at the various places where people talk about how to hack the mainframe or to go out and do attacks on ZOS. What they'll tell you to do is get something from an APF authorized library. Oh, by the way, here's a little piece of code that'll find the ACEE that you're running under and flip the bit on. Right? The operations bit or whatever bit might want to be. Right? They have a choice. Those are the kinds of things that will be slowed down. Notice I didn't say stopped. I said slowed down. Right? At least they'll be identified. We do give you a way of stopping them, which I'll talk about now. Yes, sir.
I noticed you've got suppressions, exclusions.
Yes.
Do any applications, i.e. IBM applications, get suppressed automatically? I'm thinking Command Verifier in Z-Secure, I believe, has an option where you can give temporary special or temporary operations. Would they be recorded in this, or are they suppressed?
So the question is, are there any IBM products for which one has to do suppression? Specifically mentioning the Z-Secure series of products. I am not a Z-Secure person, but I do know, having chatted with the folks, that they had a release of Z-Secure. Do we say Z-Secure or Z-Secure? I want to make sure I get it right. Z-Secure, sorry. A version of Z-Secure which eliminated the need for an exclusion. Right? So thank you, good question. But let me follow up with one of the Z-Secure experts at some point and get you the real answer. But you jumped forward. Right? Do we have the concept of exclusions? Yes, we do. In that ACEE check class, I should say, you can define the programs that you want to be excluded. Well, what programs will they be? I hear you cry. Let's take a look at the IRR 421I message. That message will come out and say, ACEE modification detected. For the user, and it gives you the user ID, it grabs out of the ACEE, in address space, in hex, tells you that. The job name, while program name is running. That's not the name of the program that flipped the bit. Add user drove a rack route request equals off. It detected that there was a modification made, and it flags that has happened. That's not the program that flipped the bit. I can't emphasize it. It may well be, by the way. It's as a former systems programmer, I feel like I'm confessing now. Hi, I'm Mark. Hi, Mark. I'm a systems programmer, and I used to flip the ACEE bits because I'm an honest guy, and I really wanted to make things work better. Oh, great. I don't know what the statute of limitations is, and I don't even know if you have a statute of limitations in the UK. So I'd like to say at my last GSE, which this will now be, because where's I going? Oh yes, as a systems programmer, I could have written a utility that flipped the bit on and did something in the same program. And in that case, the program which caused the detection is the same as the one that caused it, and life is good. But in this example, list user didn't do this. Somebody else did this. Lenny.
So at what point does the modification detection start? The reason I ask this is ACEE is normally created through bracket or whatever, and there's an exit, post-processing exit. So if I modify the ACEE in post-processing exit, am I going to be detected at that point?
Excellent.
Only when the bracket is complete?
Excellent question. So the question is, at what point do we generate that thumbprint? And I did say it's doing rack route request equals verify processing. But for those of you who are just crafty enough, you can have pre-processing and post-processing exits. And the question is, at what point does that signature get generated? I believe it's after the post-processing exit is run. Because otherwise, everything would be flagged. So good question. All right. Yes. So we talked about the program name. That's the program name you'd build the exclusion for. Hey, this guy, he detected it. It's okay. Now, I said that we will allow, we're just giving a warning, if you really want to fail these, you define a profile, irr.admin.on.failure. I like that. It's a very crisply defined name. No one will ever define that profile name by accident. Because if you do, and we detect one of these exceptions, we fail you with a new admin. Well, actually, it's an existing admin, the 4 Charlie 6 admin, with the hexadecimal reason code of Alpha Charlie Echo, or 276. Yes. That, by the way, is I think that's clever. You know my favorite? Oh, we're on a tangent here. What's my favorite wait state code? Lenny has a lead on this. It's back when we did the earliest of our B1 work. And one of the rules was if the logging stopped, the system had to stop. If you couldn't record an event, the system had to stop. So there's actually a wait state that we introduced for that. And since we're doing this for the Department of Defense, that wait state code is DOD. I think it's pretty clever. All right, any more questions on ACE privilege detection? All right.
Yeah, quick one.
Yes, sir.
You said there was a good example at the top there of ad user not being the perpetrator and there being another program. Where in that message is the other program that
You don't know.
have to define?
You do not know. You do not know who actually caused it because that could have happened days, weeks, months ago. Not in the call chain.
Oh, I see what you mean, right.
Yeah. That's the challenge. So that's why I want to make sure this isn't the magic that some people may have made it sound like. This is a good detection mechanism. It's a starting point. It's a starting point. You ready for chocolate? Oh, I love doing this. Oh, let's see if we do it better, Carol.
Rocket
I'm not going there. All right. Shall we move on? A couple of little things that have been happening in the pervasive encryption front. GES spool datasets. Our colleagues over in GES land, yes, I love that, encrypt all things, will be introducing encryption for spool datasets. There's an APAR down there that once that's closed, you'll be able to take advantage of this. The RACF support, which is completely useless at this point, but the RACF support is already there. And the RACF support is really just the ability to specify the key label that will be associated of the key that you want used to encipher those GES spool data sets. And the only thing that is interesting in this, no, there's nothing much interesting in this. The thing that's interesting is, I take it, is the GES, it's in the GES jobs class, not in the GES spool class, in the GES jobs class. So I asked earlier about how many of you were using pervasive encryption. I'm going to ask, there's a survey out there that will ask you to tell IBM a little bit about your pervasive encryption plans and thoughts. Because we really want folks to start using pervasive encryption on ZOS. The Z14 had a lot of infrastructure there to basically create a high-performance way of doing encryption at high volumes. And we want to see more people take advantage of it, and we want to know what the impediments are. All right. End of that discussion, let's talk about something called identity tokens. And this follows nicely with the ACE discussion because it's all about who you are. It's all about identities. So in ZOS, how do we assign identities? I classify them a couple of different ways. The first is directly, right? I have a user ID and a password. I log on to TSO. TSO takes that information, gives it to RACF, and boom, we create an ACE. But that's not the only way to get an identity created. The second way is I'm on TSO, I submit a batch job. Do I have to submit a password or anything like that? No. My identity flows from my TSO session into that batch job, into that initiator, and is associated with all the work done by that batch job. So that's another way, right, by inheritance. A third way is by mapping. You can go out and create mapping profiles that say, if I get this particular digital certificate presented, I will take this digital certificate and map it to this MVS user ID. We've been doing that for years and years and years. And another way you can do this is by strict assertion, right, where a resource manager says, build me an ACE for Fred. Trust me, I know I've done all the work that I need to do, but I need an ACE for Fred. A direct assertion, build me that. You have to be authorized to do that. APF authorizes some other stuff you need. Right, I'd argue that pass tickets and surrogate is also sort of a flavor of that. But this is really the concept of the resource manager says, create something for that user. Now with ZOS 2.4, RACF is introducing a new assertion mechanism. It's the JSON Web Token, sometimes called the JOT. The concept of that, it's an industry standard assertion mechanism for identity. Right? We're adhering to RFC, what's the number, 7514. The concept here is if you want to create one of these JSON web tokens, all you have to do on your rack route request equals verify is say, give me a JSON web token for this user. And we'll build the ACE and we'll return back to you the JSON web token. So later on, if you want to do more work for that user, you can take that JSON web token and pass it back into us. Now, obviously, there are going to be some controls on that, and we'll explain a little bit how this mechanism works. All right, there's a new general resource class. You have to define some stuff in. And that's pretty much the most complicated part of it, I think, is the setup for this. Now, why did we do this? Well, it turns out in that TSO example of here's a user ID and password, let's say the password was expired. Right? What happens? The request equals verify comes back to TSO and says, this user ID's password is expired, give me a new one. What the TSO then does is it takes the old password, prompts you for the new one, and passes them both into RACF. When we did that first request, when we said the password was expired, at that point, we don't care about you anymore. It's very transactional. You're done. User ID, expired password, forget about you. The next time in, we have to get the old password and the new password so we can both validate you are who you say you are and change the password. This technology ruled the world for the last 35 or 40 years. And then MFA came in. And MFA brought in the concept of these single-use tokens. Right? So if you pass in a credential that included an MFA token and the password was expired, and we go back to you and say, give me your new RACF password, that MFA token has already been used, cannot be reused. All right, so we had a bit of a complicating factor. There were some ways of getting around this, but they were really kind of a pain in the butt. So what is being done now is we're giving the mechanism for folks who are doing authentication where MFA might be a possibility to get one of these JSON web tokens back, right, that says, yes, you have been authenticated properly, and then pass it in on subsequent calls. It literally brings statefulness to the authentication process. And TSO and the IBM MFA product and other MFA products are taking advantage of that. The second reason why we did this is there are resource managers who will replay these tokens. They will take a user ID and password and pass it in once, and then a little later on pass them in again. Doesn't work with MFA. They have the ability to create these JSON web tokens and pass them in a little later on. So what's in a JSON web token? This is as geeky as it gets, and it's really nothing that you wouldn't expect. Right? There's going to be some information that's control information. What kind of encryption is used for the signatures, because you don't want these things being created by just anybody. You want them to be created and be non-mutable, non-changeable. Then you'll get the payload and identifier. Think of it as a serial number. SAF is the issuer name. It can be anything, but for the ones we're creating, we'll all have an issuer name of SAF. Then the user ID, the application name, an expiration date, the time at which it was issued, and then the all-important signature at the end. Now, whenever you have a signature, that means you're going to have a key to create the signature. We'll talk about that in a second. How do you pass this information in? Rack route request equals verify has an existing field that we're changing, IDTA. You pass us an address of a length and the actual data, and life is good. For those of you who write assembly language programs and have been doing that for RACF with rack routes and stuff like that, big change. The release equals, which probably would have been release equals 77C0 for the current FMID. We're moving away from that because in this environment where we're shipping support back so much, we are now going to a parameterless version identifier. So PLV001 is the release equals that we will use for any of the new RACF functions. When we introduce a new one, it'll be PLV0002. Right? We're divorcing the RACF release from the ZOS release because we're in the continuous delivery world. For what fun we're having with that. All right, so there is a new class called IDT data and an IDT parms class, parms segment. A couple of things: the class has to be active, the class has to be rack listed. The format of that profile is the IDT type, JWT for JSON web token. You can envision that at some point in the future we might have some other ones there. .application name, .user ID, .IDT issuer name. IDT issuer name, as I said earlier, is SAF. Application name is the applet equals value you want this to be valid for. We do allow generics. Those are the keywords you could put on the IDT palms. The most important thing here is the location of the signing key, and it must be a PKCS token package, whatever you want to call that. So this is a little bit different creation of an ICSF token object. You have some choices in the signature algorithm to use. Will you allow this token to be used by any application or just the one that's specified in the token? I don't know why we chose yes as the default. That seems like a particularly, but we did. And the length, the validity time of this token. Yes, sir.
Is there corresponding support in ACF 2.6 for this?
Is there corresponding support? So is there support? Yes, if you have the answer to that, I'd be thrilled to hear it. Yeah. So I'll be honest with you. These are a SAF level set of functions, and our colleagues over in the other kernel security managers have been very good about supporting them. And you have, okay, so you have, good. So you have it in place. Cool. As I mentioned, TSO will be taking advantage of this to help seamlessly, or help make the logon process more seamless for folks who are using the IBM MFA product or other products, other multi-factor products, when the password expires. All right, we have about 8 minutes left. A couple of other changes. Common criteria. We spent an awful amount of effort and time submitting ZOS and RACF for separate evaluations against the common criteria. It takes about 2 years to get this. So this is ZOS 2.3. It's been out for 2 years. Just got its EAL4, Evaluation Assurance Level 4+, in July of 2019. And then RACF goes for a higher level, EAL5. We got that. The other numbers there are for other releases. If you're a ZVM user, for example, they've gone through the common criteria process, as has the Prism microcode. All right, a few other things. Pervasive encryption for data sets. I know some people said with pervasive encryption you can encrypt all data, and then you had to look at the footnote. And there were some exclusions. One of the exclusions was partitioned data sets. So now with ZOS 2.4, you can use pervasive encryption for PDSs, but they must be PDSEs. PDSE technology has been out for 30 years. I think we've shaken the bugs out. Mr. Wilson, sir.
Is that going to get rolled back to 2.3, Mark, or is it just 2.4 and going forward?
This is going to be a long one. My understanding is, the question is it too low and outside and you got it? You man. My understanding it is just ZOS 2.4, but I will validate that for you. I've heard no discussions. Yes?
I think it's going back as far as 2.2.
Has for partition data sets?
Yeah, I've shown you that to be installed.
Okay.
I'm pretty sure. I'll look it up.
I yield to the gentleman who 4 years ago did a session called Dear Mr. IBM, please give me the ability to encrypt data sets. Yeah, so that was it. So you get 2 chocolates for that when I get back there. All right, so PDS, we will find out. Thank you, that is awesome. Sequential, it used to be, it had to be extended format, sequential, basic format, and large SMS managed data sets using BSAM. You see the rules up there. There's an 8-part number there. If you have EXCP programs that are running against data sets, there is some new function. It's not as easy to, I won't say it's not, you have to do some work. It doesn't happen automatically under the covers. I find this extraordinarily interesting that the people who are worrying about security 30 years down the line, when it's expected that quantum safe algorithms will be a must, we have some quantum safe digital signatures available for SMF records if you're signing your SMF records. That's a Z15 exclusion. That's cool. There's a data privacy for diagnostics, allows the tagging of data so that you can control its distribution in dumps as they go back to IBM. Setup is required, Z15 only. Network authentication services are NAS, part of our PKI services, sort of. They're supporting something called flexible authentication secure tunneling. If you care about that, tell me, I'll find out about it. PKI services enrollment over secure transport. If you have programs that are creating user key common storage, user key CSA. We've been telling you for 10 years that's a bad idea. You can no longer do that in ZOS 2.4. And if you really want to do it, there's something called the RUXA, which is you have to pay for it. So if there's anybody using this, I'm shocked. And I'm shocked. But I know there are folks out there who do that. And there's some components that we're easing out. Enterprise Identity Mapping, Open Cryptographic Services Facility, the Open Cryptographic Enhanced Plugin, and PKI Trust Services Policy. That's not PKI Services, that's a small little element of it. All of these represent things that we are fairly certain nobody is using. If you are using, this is a statement of direction. If that direction bothers you, contact IBM. All right, requests for enhancements. This should be no surprise. You can ask us to make changes. There's the URL to use. We have a team that meets twice a month that looks at all these requirements, and we are getting a lot more of them now, so thank you very much. We call that job security. Want some more information? All right, podcasts. Marna Wally is here, Martin Packer is here. They've got a podcast. It's great to listen to. There's another one called Terminal Talk. Frank DiGilio and Jeff Bisty. Both of these are good. The Terminal Talk is a little more goofy and entertaining because Jeff and Frank are a little bit more goofy and entertaining. Marna and Martin tend to be very geeky, and I love them both. So yeah, good sessions. You can pick them up. Great to listen to when you're driving. Shameless plug number 2. There's a series of videos created by the guy standing there, the Enterprise Knights of IBM Z. These are short, digestible, 3, 5, 7, 8 minutes probably is the longest one. I think I have the longest one out there. On a whole series of topics related to security on Z. And they go to, some of them go down, fairly detailed. The ET Def ones, for those of you who are doing cross-memory services stuff, a nice, simple explanation. We created these with the intent of making them for new hires, people new to the platform, and it turns out it's a great review for everybody. For all the red books, how many folks read red books? Excellent. I love the red books. I didn't update. It should say the Z15 technical introduction. Sorry about that. There's a whole bunch of good ones. I can't go out and compliment them enough. They're absolutely wonderful. The IBM books, the product books tell you what it's supposed to do, and the red books tell you how it actually works. I love that. We have a group of folks, the PET Test Platform Evaluation Test folks. They are one of the last groups that get a hold of all of the IBM products. They put them all together, and they blog their results. The good, the bad, and the ugly. Go check it out. And questions. Other questions? On time. This never happens. Yes, sir. Oh, we got 2.
Well, you're talking about Pervasive encryption, you're talking about the server.
Mm-hmm.
So the 2 issues I have are temporary data sets and tape data sets. And these are holding you back big time.
Okay, so the question is pervasive encryption, 2 things holding you back, temporary data sets and tape data sets. Temporary data sets, in my opinion, the solution is erase on scratch.
I understand that. And we've done the work to try and, we started to do the work to try and do that.
Mm-hmm.
And the number of SMF records that we looked at on the test system indicates, as you said to me before, it's likely that most of your strategies are going to be for temporary data sets.
Mm-hmm.
There's so much SMF data generated, we can't afford to turn on the SMF records to do the analysis on our production systems.
All right.
So it's a sort of, it's very difficult. So these, we have some mechanism for encrypting temporary data sets.
Okay, so that's option 1. If instead of encrypting them, the option were to give you a much faster way of scratching them, would that be sufficient? The fear with the temporary data sets, in my experience, has been the time it takes to erase. And we made great progress in ZOS 2.1 and 2.2.
But the problem was the time it took to analyze how
My question, what if we said that the analysis would be 0 because the time to erase would be near 0? Okay, so that might be. All right. So tape data sets and temporary data sets, I will take that back. And so you had a question in minus 10 seconds?
Quick one on red books. MFA, red book is version 1.1. MFA is at version 2.
2, yeah.
But we can get a new red book.
I will find out from my Red Book colleagues. Some of my friends worked on that one. So the question is, the MFA book is at version 1, IBM MFA book is at 1.1. When's 2.0 coming out? I'll find out for you. I got a chocolate for you.
I'm sorry, time out.
Yeah, we have to.
Mark, thank you so much.
Thank you.